Good morning, students. In our today's class, we are going to discuss about problem number 20. About problem number 20. What is that? So here, two cars are given. Two cars are given. Car A is here, and this is car B. This is here. What is the distance between these two cars? These two cars. Distance between these two cars is 150 meters apart. 150 meters distance. 150 meters apart, and they are with they are in journey with velocity is 10 meter per second, and second one with velocity 12 meter per second. Then what happened? Both drivers applied brake simultaneously when they are maintaining 150 meters distance. When they are maintaining the 150 meters distance, both drivers applied brakes for the cars. Then what happened? Slowly their velocity reduces. Their velocity reduces to 0 while reaching this location. Slowly the velocity reduces to 0 while reaching this location. Observe here, v is equal to 0 meter per second. When he applied brakes, when its velocity is 12 meter per second, he applied brakes. With a is equal to 2 meter per second square deceleration, the velocity becomes 0 after traveling a distance s2. Here also, when its velocity is 10 meter per second, he applied brakes. He applied brakes. With acceleration 2 meter per second square, it reduces its velocity v is equal to 0 meter per second and travels a distance of s1. And this is the distance remains to cover. This is the distance remain to cover out of 150 meters. So it covers a distance s2 and it also covers a distance s1. And what is the rest distance to cover so far? Without covering only, they came to halt. So what is the remaining distance? This is what he is asking. This distance he is asking. The total is 150 and this is S1 and this is S2. So how to proceed? 150 minus S1 plus S2. S1 plus S2 minus the whole distance, 150. Then you will get this remaining distance. Okay. For that we need to calculate first of all S1. By using the formula V square minus U square is equal to AS. Yes, I written here as a S1. What is V? Here you consider this diagram. What is V? Final velocity 0. V square 0 square minus U square. When he applied brakes, its velocity is 10 meter per second. That's why U is equal to 10. So here 0 square minus 10 square is equal to minus. Why I am writing minus here? Because it is under deceleration. That's why I am writing here. A is equal to minus 2. 2 and minus here. To S1 as it is. Now just by simplifying this, minus 10 square is equal to 100. That is equal to 2 2s are 4 minus as it is S1. So S1 is equal to 100 divided by 4. You will get 25 meters. Similarly come on to this one. While it is traveling here, its journey with the velocity is 12 meter per second. He applied brakes. Then its velocity reduces to 0. The same formula we are going to use for this. V square 0 square minus U square. Initial velocity when he applied brakes 12 meter per second. That is equal to 2 into what is acceleration? Both are maintaining same acceleration. While they are decelerating, it reduces its velocity. A is equal to 2. S2 is the distance covered by this. By substituting these values, 0 square minus 12 square is equal to 2 into 2, 4 minus stands for, that is it is under deceleration, S2. Minus 144 is equal to minus 4, minus will get cancelled, 140 by 4 is equal to 36 meters. Now what is our remaining distance? 150 meters total distance minus the distance traveled by the both cars. 150 minus S1 plus S2, that is equal to 150 minus 61, that is equal to 89 meters. Just to go through it once. Okay, noted. Next sum. In your next sum, a car travels a distance. A car travels a distance with initial velocity u meter per second and acceleration 3 meter per second square. Okay. After some time, we don't know the time. After some time, t1, he applied brakes. He applied brakes. Even though that travels a distance, because when you are applying brakes, instantly that vehicle will not come to rest. If it come to rest, it will fall down. So after applying brake, it will travel a distance with acceleration 2 meter per second square. With acceleration 2 meter per second square, and it travels up to a time t2 after applying brakes. That means it means few seconds. Sum of these 2 seconds. So it means it is accelerating. It is accelerating up to certain distance and decelerating up to certain distance. And total time of journey is 10 seconds. Time of journey is 10 seconds. That I can write like this: t1 plus t2 is equal to 10 seconds. Here a vehicle accelerates first for t1 seconds and decelerates next for t2 seconds. The total time of journey is 10 seconds. The total time of journey is 10 seconds. Then our questions are: what is the distance covered by the vehicle while accelerating and decelerating? What is the distance covered by the vehicle by accelerating and decelerating? And what is its velocity after 4 seconds? Okay, this is what he is asking after t1 seconds. T1 seconds. Okay, now come on, listen. First of all, we need to get the time values. For that, we went for the equation v is equal to u plus at. V is equal to final velocity. We don't know exactly that, we need to calculate. V is equal to 0 plus 3t1. 0 is initial velocity, no, that's why I am writing here 0 meter per second. 3t1, 3 is acceleration, t1 is a seconds. Now v is equal to 0 plus 3t1 can be written can be written like this: v is equal to 3t1. This is equation number 1. We got the relation between t1 and velocity. In second case, when it is decelerating, with the acceleration, a is equal to acceleration with the negative sign is a deceleration. A is equal to minus 2 meter per second square. So by using the same formula, v is equal to u plus at, here also we will get 0 plus v minus 2 t1. Observe here why I am writing v instead of writing u, because when any object accelerating like this, its initial velocity is taken as 0 meter per second and final velocity is here. When he applied brakes, for the second half of the journey, the initial velocity is nothing but final velocity of first half of the journey. This is the first S1 and this is S2. From here to here, it is the initial velocity and here it is the final velocity. This final velocity is initial velocity for next journey. Here he applied brakes. Its final velocity becomes 0 here in second case. But what I am saying here is, the final velocity for the first journey is nothing but initial velocity for the second journey. Okay, that's why I am writing here. You can read, you can listen this repeatedly for this statement. That's why I am writing here. Instead of writing u, I am writing v. I am writing v minus 2t1. Acceleration is equal to minus 2. That's why I am writing here t2. Now what we got? We got another relation between v and t2. Observe here, LHS are equal. Can we equate these two? Sure, you can equate, because the same journey. 1 is equal to 2. 3t1 is equal to 2t. So here 1 is equal to 2. Here 1 is equal to 2. These two are same. Then what will you get? 3t1 is equal to 2t2. 3t1 is equal to 3t1 is equal to 2t2. Implies t1 is equal to, bring this 3 on opposite side. 2 by 3 into t2. What he is given, t1 plus t2 is equal to 10 seconds. Just do one thing. Do one thing. Here, instead of writing T1, you can write 2 by 3 T2. 2 by 3 T2 plus T2 is equal to 10 seconds. Multiply with 3 on both sides. Multiply with 3 on both sides. Then 2 by 3 and 3 will get cancelled. 3 T2 is equal to 30 seconds. That's why I am getting here a small simplification here to remove this denominator. So while doing this calculation simplification, 2T2 plus 3T2 is equal to 30 seconds. 5T2 is equal to 30. T2 is equal to 30 divided by 5. That is equal to 6 seconds. When T2 is equal to 6 seconds, T1 is equal to 4 seconds. Okay, right? We'll go for, note it down here. Note it down, everyone. Note it down. Okay, we'll go for next. Observe this. At t seconds, its velocity v is equal to t seconds. I mean 6 seconds. We got no 6 seconds. We got previously we got 6 seconds. Up to 6 seconds, it decelerates. When it decelerates, its initial velocity v is equal to 2 into 6. That is equal to 12 meter per second. 12 meter per second. Okay, you are getting some. Look. Now, what is the total distance during 4 seconds and during 6 seconds? During 4 seconds means half at square is enough to get that. Half at square, because initial velocity is 0. Ut plus half at square. When u is equal to 0, you will get half at square only. Half a is equal to 3. T square is 4 seconds. No, 4 into 4. 4 into 4. Then by simplifying this one, you will get a 24 meters. 24 meters. During 6 seconds, it decelerates. By using v square minus u square is equal to 2as. V square minus u square is equal to 2as. S is equal to v square minus, you know, that formula. I'll write here. V square minus u square is equal to 2as implies s is equal to v square minus u square by 2a. V square minus u square by 2a. Okay. You all know that it is under deceleration, so this v square becomes 0. 0 square minus u square. Since it is decelerating, you are writing here minus 2a. Minus 2a. That's what I written here as a u square by 2a. Okay. I hope you understand this. That's why I am writing here s6 is equal to minus u square by 2a. Minus u square by 2a. So here what is its velocity? We got previously our velocity v is equal to 2t2. 2t2. Here, come on. Here we written no velocity is equal to 2 into t2. T2 is equal to 6 seconds. That's why I'm writing here 2 into 6 as a v. 2 into 6 as a v in this. Here 2 into 6 as a v. 2 into 6 as a v. Square as it is, minus will get cancelled. So 2 into 6, 2 into 6, 2 into 6 one time, 2 into 6 second time, divided by 2 into 2. That is the acceleration. So by cancelling these two, you are getting 36. 36. What is the total journey? S4 plus S6. That is equal to 24 meters plus 36. How much it is? 60 meters. 60 meters. So we got our answer. Note it down carefully. You are getting sun rays. So no problem. Go through these ones. This is for clue. How you are getting this formula. No need to write this one. Okay, on Monday I will explain about mathematical physics. Today I have a lot of work. On Monday we will have class. Okay. Bye.